Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and today we continue to discuss topic number 3 of P4 or Pure Mathematics 4, and we'll be looking at example 2, and it's just an extension of what parametric equations are. And in this question we told that x is equals to ln t plus 3 and y is equals to y 1 over t plus 5, and t itself is greater than negative 2. Part A of the question is find the Cartesian equation in the form y is equals to fx. Of course, x is greater than k, and k is a constant to be found. That is part A. That is part B of the same, but let's first of all deal with part A. The fact that we have x being equals to ln t plus 3, this is the same as saying ln is of course log to base e, x is equals to log to base e of t plus 3. And as you know, this simply means e raised to power x is now equals to t plus 3. If you employ the anti-clockwise movement, you'll realize that e raised to power x is equals to t plus 3. If you want to make t the subject of the formula from this point, you're going to say that t is equals to ex minus 3. And of course, that being true, there is what y is. Y is equals to 1 over. Now t becomes e raised to power x minus 3 plus 5. And the whole thing becomes now y is equals to 1 over e raised to power x plus 2. Because of negative 3 plus 5 is obviously positive 2. But it is important to note that, okay, this is the equation now of the function, but what is the range and what is the domain? We need to ask ourselves those questions. So because we are told t is greater than negative 2, assuming that t is negative 2, when t is equal to negative 2, then x itself becomes ln negative 2 plus 3, which is ln 1, and everybody knows that ln 1 is equals to 0. That means what? That x is meaning x is greater than 0. That's what we mean. And the Cartesian plane, of course, it is important. The Cartesian equation is y is equals to 1 over x plus 2, that we know, and x is equals to 0, so we rewrite it. Y is equals to 1 over ex plus 2, and x itself has been established to be greater than 0. That means so when x is 0, when x itself is 0, then y becomes e raised to power 0 is 1, and 1 plus 2 is 3, so y is equals to a third. Y is equals to a third. As x increases, and let's say like 1, 2, 3, the denominator also, as x increases, the denominator also increases, and therefore y decreases. But as y decreases, it is important to note that y will be 0. The reason why the reason why y will never be 0 is because even when y is 1 over a very big number, we of course tend to look at y as a very small number, because 1 divided by a very big number, it's never 0. That means y y itself approaches 0. So as you will always see that the value of y, the maximum, is going to be a third. Therefore, the range of the function is going to be y in between. It will always be greater than 0 because 1 divided by any number is not 0. And it will never be greater than a third, because when x will be the most possible value, which is going to be 0, then y itself is a third. So this happens to be the range of the function. But let us just look at part B of the question. In fact, it's just like we've answered the part B of the question, because part B is asking, write the range of fx. Write the range of fx. The range of fx, we have just established it. And the argument is, when t is equals to, let's just do it. When t is equals to -2, y is equals to 1 over t plus 5, which is a third. That we have established. As t increases, y decreases, but it's always positive. Y decreases, but it is always a positive number. There is no way y will ever be a negative number. So the range be positive. So the range y is going to be always greater than 0 and always less than a third. And that is exactly what we have established up there. Okay.